All right, so we are continuing factoring. So we are still in 9.3. And we are continuing 3 different other types of factorings in addition to the GCF methods. So I do have a roadmap to factoring that I want to show you. It's a little flow diagram. And it's the process that we're going to follow when we are factoring any type of polynomial. So the first thing that must happen is the polynomial must be in standard form, right? So you have to have the largest exponent as the first term and then work your way down to the lowest exponent. If the polynomial is not in standard form, you can't properly factor. So you always need to start in standard form. Okay, so after it's in standard form, you need to look to see if you have a GCF. So that is always the first thing you're going to do. So you want to look at the entire polynomial and determine, okay, does it have a GCF? Yes, then you're going to factor out the GCF. If the answer is no, then you're going to look for special patterns. So let's say yes, there is a GCF. We factored out the GCF, and then we're looking at what's left in the parentheses. So we're ignoring the GCF out in front of the parentheses. We're looking at what's inside the set of parentheses. Then we want to look for a special pattern. Okay, so looking for a special pattern, what does that mean? Well, these are the 3 other types of factoring that we're going to talk about today. One is called a perfect square trinomial, and you'll kind of see this is supposed to have a squared. You'll see what we're talking about today with a perfect square trinomial, but this is the pattern you're going to see, and your end result should look something like a plus b squared or a minus b squared if it's a perfect square trinomial. Okay. We're also going to be talking about the difference of 2 squares. So it's a squared minus b squared. Notice difference means subtraction. So it must be subtraction here, not addition. Okay. And then you're going to get the pattern of a plus b times a minus b. And again, we're going to kind of go through a couple of examples here in a few minutes, but I just want to show you this roadmap in this little diagram. If it doesn't have a special pattern, so the answer is none, it's not a perfect square trinomial, or it's not a difference of 2 squares, then you're just going to factor. And we're going to talk about what that means as well and what it means to just straight factor. So these are 2 different like special patterns that we have when it comes to factoring. So use this to help you as you're going through, especially when it's a mix of all those type of factoring problems that we've been talking about. This is really going to help you narrow down the proper process and the way to factor the polynomial. Okay, so let's get started with some notes. So here we go. Vocabulary. So the first vocabulary, a blank trinomial has the form. This is our perfect square trinomial. So a perfect square trinomial has the form of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. Okay? And the rule right here is saying that for each of these 2 forms, so let's go with the first form where we have the plus 2ab. When you factor it out, it's going to become a plus b times a plus b, which then we can rewrite as a plus b to the second power, right? The only difference between this first rule and the second rule is that this plus sign becomes a subtraction sign, which then changes these plus signs to subtraction signs, so you get a minus b quantity squared, okay? We're going to talk about what that kind of looks like here in a second and what a squared plus 2ab plus b squared kind of looks like when it comes to trinomials. But the other thing I want to point out and discuss real quick is the difference of 2 squares. So a squared minus b squared. You're going to get this product of a plus b times a minus b, okay? So we're using the word squares a lot. I want to remind you what squares are. And you got to think of the exponent of 2. So I'm just going to go up to 5 for the sake of time, but you should realistically know up to your perfect squares up to 15. So 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25, 6 squared is 36, 7 squared is 49, etc. And you should know them and I'd be able to identify them all the way up to 15 squared, which is 225. Okay. Something that we don't also think of as squared is x squared. Right? X squared. Oh, now my pen's going to die. X squared is x times x. Right? So that's a perfect square as well. X to the fourth. Because it's x squared times x squared. Right? Anything that's a perfect square is something times itself. X to the sixth. X cubed times x cubed. Now, remember, when you're multiplying terms, you add the exponents, right? So then x to the eighth is x to the fourth times x to the fourth, right? These are things that you should keep in mind as you go. These are all perfect squares, all right? So let's look at a couple polynomials. All right, so regular factoring. So this is part of this part down here. All right, so we're going to talk about just regular factoring. All right, so you have a polynomial, x squared plus 7x plus 12. All right, so to factor this guy, we're going to break it down into two sets of parentheses. Okay, so we're undoing the FOILing process. So remember that from yesterday, from the previous notes lesson, we talked about how factoring is undoing the multiplication process. And to undo this, when we undo this, it's going to become, we're undoing that FOIL method. So we're going to break down this polynomial into two sets, into two binomials, okay? Two sets of parentheses. So what we're going to do is the first term, I'll try and color code for you. The first term in both sets of parentheses should be this term broken down. What do I mean by that? Well, this is x squared. So how do I break down x squared into two equal terms that when multiplied together give you x squared? It's x and x. So this becomes x and this becomes x. Okay. Then we want to break down 12. Now, 12 is not a perfect square, right? But we want two factors of 12. And when I say factors, they multiply to become 12, but then they add up to become positive 7. So multiply to be positive 12, add up to be positive 7. So what are factors of 12? Well, factors of 12 are 1 and 12, 2 and 6, and 3 and 4. So what combination gives you, what combination multiplies up to 12 but adds up to 7? It's going to be this combination right here. Right? So then it doesn't matter the order. One side can get 3, one side can 4. Again, order does not matter as long as you keep the signs the same, as long as you keep the signs consistent. And what do I mean by that? What sign goes in the middle here? Addition or subtraction? I need them to add up to 7 and multiply to positive 12. So they either both have to be positive or both have to be negative, because a positive times a positive gives you a positive 12, and a negative times a negative gives you a positive 12. But I need the 3 to be positive and the 4 to be positive, so that way we get the positive 7. So plus and plus, that is my answer. So my answer is going to be x plus 3 times x plus 4. All right, so let's do it again. We'll walk through it again together. My parentheses, right? We're undoing that FOIL process. I take the first term and I'm going to break it down into two equal terms to start off each set of my parentheses. So g squared is going to become g and g. Then we've got 10, so I need my factors of 10, so 1 and 10, 2 and 5, and I think that's it. So now I need to look for my factors that multiply to positive 10 and add up to positive 7. Well, that's going to be 2 and 5. So 2, 5, They both need to be positive, so that way they add up to positive 7, and they multiply to 10. Okay, here we go. Let's do another one. My set of parentheses, take the first term, split it into 2, v and v. I'm going to take my last term, which is 20. Now, notice it's negative. Okay, we'll get there. I want you to just work with 20. We've got 1 and 10. Oh, I'm sorry, 1 and 20, 2 and 10. 3, no, 4 and 5, 6 and nothing. Okay, so we're done. Now, notice how 20 is negative. All right, so we need one of these to be positive, one of these to be negative. So I'm going to go ahead and put one positive, one negative down. Positive, negative. Again, order does not matter. So if you had them switched, not a big deal. Okay. All right, so now we got to figure out what combination here multiplies to negative 20. Well, we've got the positive and the negative, but needs to add up to negative 21. So which one of these? One positive, one negative, that adds up to negative 21. I think I goofed. I'm sorry. Yeah, I goofed. I'm sorry. Make this positive 20. Okay, now it works. So that means this is then going to change. One of these is going to change. Are they going to both be positive or both be negative? And the trick is to look in the middle. So this middle number has to be negative 21. So if it has to be negative 21, can I have two positive numbers? No. I need to have two negative numbers. So that way it adds up to negative 21, but multiplies to a positive 20. So my answer is going to be 1 and 20. So v minus 1, v minus 20 is going to be my answer. All right, last one. Here we go. Two sets of parentheses. Split up that first term into A and A. We're looking at the last number. We're looking at the constant. We've got 27. Okay, again, we're going to ignore the negative for right now until we look at that middle term. So first, we're just going to ignore the negative. We've got 1 and 27 for the factors. We've got 2, no, 3, and 9. 4, nothing, 5, nothing, 6, nothing, 7, nothing, 8, nothing. That's it. We're done. Okay? So now, negative 27. So 1 has to be positive, 1 has to be negative. All right? So I'm going to put positive, negative. Okay? What's the number in the middle? The number is positive 6. So we need a combination here of 1 positive, 1 negative, that we get positive 6 in the end. So I know I can make 6 between 3 and 9. My 9 has to be positive, and my 3 has to be negative. Okay? Now, again, if you had this switched and you put... I want to finish boxing that first. All right. If you had this switch and you had the negative here and the positive there, that's fine. As long as your 9 and 3 corresponded with that, meaning it has to say plus 9 and it has to say minus 3. But if you had these binomials switched, that's perfectly okay. So it can read a minus 3, parentheses, times a plus 9, parentheses. That's fine. It's the same thing. Okay. So that is just factoring. That's regular factoring with your a squared plus bx plus, with your x squared, plus bx plus c. Okay. Now we're going to get into two specific types of trinomials or binomials and types of factoring that have more specific patterns. So it's like what we talked about up in the beginning with the vocab words up here with the perfect square and the difference of two squares. Okay. And it also is on your roadmap to factoring down here at the bottom. So, I'm actually going to use this to help us. All right. So, a perfect square trinomial, which is this guy right here. All right, so we're going to talk perfect square trinomials. Now, this is when we talked about our perfect squares. This is when this comes into play. You need to be able to recognize these without having to look at them every time, right? This is something you should already know. When it says perfect square trinomial, that means the first term and the last term are perfect squares. So it should be on this note card. It should be on this list. Now, x squared is on here. 16 is on here. So that means this is a perfect square trinomial. Look at the subtraction sign. So that means I'm going to have a final answer that looks like this right here. Okay. You can factor it the exact same way that we have done above. That is not wrong. You will not go wrong with that. Okay. This is just for you to notice a pattern. And it has a special type and it has a special name. Okay. But we can factor it the same way we just got done factoring the other examples. So you're going to have two parentheses. We're going to break up that first term. So x and x. You can even write out your factors if you want. So this is continuing the same method we just completed. All right. 1 and 16, 2 and 8, and 4 and 4. Now, we need positive 16, negative 8, which means are we going to have plus plus or minus minus? Minus minus, okay? And then we want to look for that combination of factors that can get us negative 8, and it's going to be minus 4 and minus 4. This is not fully simplified. This is not our answer, okay? We can simplify this because this is the same thing as writing x times x. We would never leave x times x on a paper. That's just silly. We would always simplify it to x squared. So we're going to simplify this to x minus 4 parentheses squared. Okay? So there's nothing wrong with completing and factoring these the exact same way we just got done factoring all of the other trinomials. Okay? But as you complete more perfect square trinomials, you're going to notice this pattern of finding the square root of that perfect square, putting that in the middle, and it's always going to work out. And what do I mean by that? Let's walk through this example the way I just kind of said. So 2 sets of parentheses, right? You always break up that first square. And now because this is also a square, we're going to break up that square. What is the square root? What's the number that blank times blank, and as long as those blanks are the same, give you 64? It's going to be 8 and 8. Okay? Now, positive 64, so it's either going to be plus plus or minus minus. We look to see that we need positive 16, so it's going to be plus plus, right? And then we write our final answer as n plus 8, parentheses, all squared. Again, you don't have to factor it this way. If you want to just remember one way of factoring and do it this way every time, that's fine. And the more you do it, you might pick up on these patterns a little bit more specifically. You might be able to identify them quicker. That's awesome. If not, there's nothing wrong with this method. You're going to get to the same place. All right. So this last one, this last method down here, the difference of two squares, this is something that, so we're going to use this circle. This is something that you can't necessarily use the other factoring method that we just got done working with. This is something that you're going to have to use the pattern that we're talking about. All right. So the difference of two squares, difference means subtraction, right? So it always needs to read subtraction in your polynomial. Otherwise, it's not a difference of two squares. All right. Difference of two squares, meaning the first term must be a square and the second term must be a square. Okay. So the way it's broken down, it's a squared minus b squared, and then it becomes a plus b and a minus b. So what does that look like? Well, we're going to have 2 sets of parentheses. Okay. We're going to take the first term and we're going to break it down into its factor. So how do we break down x squared? We break it down into x and x, right? According to my pattern, one of these is going to be positive, one of these is going to be negative. So plus, minus, order does not matter. Okay. And then one thing I want to point out to you is that A and A have to be the same. B and B have to be the same. It's the signs in the middle that are changing. So what is the square root of 81? So that way the factors here are going to be the same. And the answer is 9. So you get x plus 9 and x minus 9 as your answer. Okay, and that's it. Guys, as always with factoring, you can always double check your work by then taking this, foiling it and multiplying, and seeing if you get the same thing in return. Okay? The key thing here is when you have one positive and one negative term, as long as these factors are the same, your middle term should cancel out. What do I mean by that? See how this doesn't have, this has, whoops, let me change this. See how this polynomial here does not have this middle term? That happens for a reason. It's because this is positive and this is negative, and your factors are going to cancel out. If you don't believe me, watch this. So let's FOIL this guy. X times x gives me x squared. X times negative 9, negative 9x. 9 times x gives us plus 9x. Positive 9 times negative 9 gives us negative 81. What happens to these middle terms right here? They cancel. So we're left with our x squared minus 81. Right? That's why it's a difference of 2 squares. That's why this pattern is the way it is. All right? So let's do this next one. So you're probably looking at this next one going, well, that's much different than the one we just talked about because this one is x squared and this one's 4x squared. Well, guys, what do you know about 4? That's a perfect square too. That's a perfect square too. Yeah. Is it on my card? Yeah, it's right here. I'm sorry, it's right here. 4 is a perfect square. X squared is a perfect square, right? 121 is a perfect square. It's one you should recognize right away. So let's break it down. Parentheses. 1, 2. Break down 4x squared into 2 equal terms. Well, I know my x and x. How do I break down 4? 2 and 2, right? What about 121? What's the square root of 121? 11. One gets a plus sign, one gets a minus sign. Circle it, and you're done. Okay?